Hello everyone, welcome to our April AfricodeX. Today we'll be hearing from Paul Kalebu, who will be giving us an introduction to Git. As you may know, Git is a version control system, and what we hope that you'll know at the end of the session is understanding of Git, what you can do with it, and basic commands. A little bit more about Paul. Paul was born in Uganda and moved to the US when he was 14 years old. He's always been interested in making things and learning about the world around him. At MIT, he majored in electrical engineering and computer science. After college, he worked on his master's degree for a while before joining a friend's startup. He now works for Apple as an embedded software engineer. He snowboards and learns about soccer's technical side outside of work. Anything positive to keep his mind and body active. Take it away, Paul.
Okay. Yeah, as I mentioned, we'll be talking about Git. Super useful tool, but very confusing to get started with. Um, and today we'll be going over just some basic concepts, just an overview of Git, what Git is, basic Git commands, and then sharing your work. So publishing to GitHub, working with others using Git, and then go through undoing changes you make, and what the different commands look like, what the differences are between them, and then wrap up with some best practices. So before we get into Git, I would like to describe version control. So here we have a problem where, um, I, used to do this a lot in college where if I have a project, but I keep making changes to it and I keep sharing it, I'd keep folders or zip files of the project on my desktop. And if I'm working with a teammate or whatever, I would like send them an email of the project or whatever, or we would have a shared Google Drive, where we're sending these things back and forth. And between one and two people or just by yourself, sure, this works. But as you could see with version 27, 28, 29, it gets out of control after some time. So this is not a manageable or scalable way to collaborate with multiple people. Proper version control involves having a timeline of changes and being able to explore these different versions of the projects. The easiest way to explain this is like essentially time travel for your project. You're able to go back to different states of this project, so these different versions, as you see version 0.1, 0.2, version 1.0, and also have independent timelines for independent change streams. So if you're working on features that aren't related, there's no need to wait for feature A to be complete so you can start on feature B. You could have a different timeline where you're separately working on both of them, and once you're done, you know unify them with the main timeline. And yeah, there's a lot of stuff here, and it all probably doesn't make sense, or maybe it does, but if it doesn't, hopefully by the end of this, there's a little more that you understand. So some benefits of version control, as I alluded to earlier, you have a reliable record of all the changes you're making. So you could go back and take a look at what changes were made, and be able to understand why some changes were made. This is especially useful if you're working with legacy code and you didn't write this code, you just joined this team, you're an intern or just a new grad. Trying to understand why some changes were made, as opposed to just reading an ocean of code. It also helps to just be able to know like who made what changes, for information sharing. It also allows for multiple change streams, as I mentioned. So if you have independent parts of the project you're building, they don't have to block each other. They could happen in parallel. This also flows into concurrent collaboration. So in addition to these multiple change streams, you could have multiple people working on this project without needing to necessarily wait for each other. They could all get their work done much faster this way. This also makes it easy to undo unwanted changes. Having different states of the project kept in your record allows you to return to states that work, and gives you the freedom to make various changes without fear of breaking anything. And if you do break anything, you just return to the known working state, within reason, of course. And version control isn't primarily supposed to be used as a backup, but as a last resort, it works decently well. Although, yeah, it's recommended against. But if you find you need to work on a new machine, and let's say your laptop, um, you spilled water on it or whatever, and your work's up on GitHub, you could go ahead and retrieve it on another machine pretty easily, as we'll see moving forward. So, enough of version control. What is Git? Git is essentially a distributed version control system. Um, as you see on the right, you could have a centralized version control system or a distributed version control system. There's very many other different designs for this as well, but these are kind of the main two. In a distributed system, every developer's copy of the system has a full history of all the changes. So this would essentially allow me to work on my code and still be able to view all the history if I'm on a flight, for example, and have no access to Wi-Fi. Some of the benefits of Git include performance, so being able to make these changes, access the history of all the changes, and contribute to the shared repo pretty easily. And then security. So not anyone who wants can access this repo. It's protected with encryption, and only those who are granted access are able to use it. Another benefit, though, is flexibility. So a core concept of Git, as we'll see moving forward, is these branches, which allows for flexibility with developing various features at the same time, and also having various commits and states of the project stored across a timeline allows you to flexibly explore the project and change between states as you see fit. So a little more on just the general structure of a Git repo. We'll get a little more into this as we keep going. Yeah, as I mentioned, you have this timeline of these various states, and these states are called commits. So as you see, commit A, B, C, and D across this timeline. And then you have all these commits on a branch. And as we'll see, you could create many different branches based off of what you're working on. And then once you're ready to return to the main branch, you go through what's called a merge. And then whatever branch you're on, there is what we call a head that points to where you are. This concept is a little difficult to understand, and may not be super relevant for some of the more basic things we're going to pick up, but it begins to become relevant as you start to do things like undo your changes or try to check out different branches, as we'll see. Right, and so if you, for example, check out commit B, for example, your head would move from the most recent point, commit D, to commit B. And this puts you in what we call a detached head state. So usually head points to a branch you're on, but if you check out a commit, you're not really on a specific branch. You're just, I guess, hanging out in this commit state. So that's called a detached head state. It's the best way I could describe it without, derailing into too much detail at this moment. Yeah, and as I mentioned, if you're working on a separate feature, you could create a separate branch, contribute to your feature as needed, and later merge it with the rest of the project. At this point, we'll kind of just go through how to create a repo, how to clone, and then creating a different branch and just kind of exploring what that looks like. So here, let's say I've created my repo. I'll show you some of the files we have, and let me know if you can't see this. I'm supposed to be presenting my terminal. I know there've been issues with presenting, so if you can't see it, please let me know.
You can see it great. Thank you.
Awesome. So as you see in my folder here, I have, before all the files, I have a .git file, a .git folder. So this holds just some information about the repo itself, if you can see here. So there's stuff about where my head is, and just general logs, various information just about the repo itself in relation to Git. We won't get into this today. This is kind of out of the scope. But as you see, this repo has been initialized to work with Git's version control system. And so some of what we want to do here is look at some of the previous commits that were made to this repo. And the way we do that is by running git log. So, as you see here, I've made an initial commit to the repo to just kind of get started with what we're working on. And you can also run a git status just to see what is the status of things in this repo. I usually like git status because when I'm trying to make changes, it helps understand what has been committed, what hasn't been committed, what's still pending, and just give you a bearing of where you are in this repo. In addition to that, you have various branches. And so you could list those various ways. Yeah, so as you see, I've been playing around in this repo a lot, but I'm currently on the main branch. And you can switch around based off of what you're doing. This allows you to kind of keep a main branch of everything that's clean, and you could open a new branch to mess around and try out new things without fear of it, ruining the working state of things that you have. So at this point, we'll go ahead and add a new commit just to see what that looks like. As you can tell, this repo, just to give you a little background, is let's assume we're working on a Friendsgiving project. We're trying to create a menu and recipes. For those who might not know, Friendsgiving is based off of an American holiday, Thanksgiving. Thanksgiving, usually most people go home and meet up with family and have this big dinner or lunch or whatever you want to call it. But Friendsgiving happens around that time as well, where instead of going home, you maybe meet up with friends and everybody brings food they've prepared and you all share it. It's a lot of fun. So we'll be doing something similar today. So in this project, we're creating a menu and also keeping a list of various recipes. So right now, let's look at our menu, see what we have. There's nothing in the menu just yet. And then for the recipes, we've got green beans, plantains, turkey. So let's go ahead and add that to the menu. And you can use whatever editor you want. I'm just using Vim today because it's fairly easy to go along with, but VS Code is another popular one. So after we've added stuff to the menu, we get our bearing with git status. So git status shows us the menu file has been modified. And so to commit that, to say, I want to keep track of this change, first we got to add it. So adding so as you see, it says changes not staged for commit right here. Adding then stages that change. If I say git status again, changes to be committed. So that change has been staged. So now I'm ready to commit the change. All right. Yeah, and that's pretty much it. So if I run a git status now, everything's set, and it looks like I have one commit, as you'll see in the log, added food to menu. And your commit messages usually should be pretty informative. Depending on what team you're working on, there might be a special structure to what these commits are. And it really very much depends on what norms your team decides to set. Yeah, I think that's pretty much it. Let's see. We'll take a look at how we could then, publish this stuff onto a shared repo and possibly collaborate on some of this work. Okay. Yeah. So we'll get into it. GitHub. You probably heard a lot about it. Maybe you've used it in an internship or in school. GitHub is a hosting platform for Git repositories. So the repository we have here in this project is a local repository. So it's just code we're working on our computer. This hasn't been published yet, and a clue for that is, as you can tell, I already have a repo on GitHub, what you call a remote repo. And since we made a commit but didn't publish it just yet, the local branch, is ahead of the remote repo because we haven't updated those changes. And once we do, then somebody else, let's say we're user A, somebody else, them being user B or user C, is able to access those and also make their changes as needed. I see GitHub also as Instagram for code. There's a lot of cool repos out there on various projects. It could be like MP3 player or some sort of video editing software, various other things that, like developer tools. It's really just like a free-for-all. Program is publishing cool things it built and trying to show them off. And there's alternatives to GitHub as well. People use various other tools, other platforms. So one of them is GitLab, and then you have Bitbucket. Gitkraken is another one as well. So you're not really limited to GitHub, but it's one of the most popular ones, especially for open source projects. Okay, so before getting into unifying branches, we'll take a look at how we publish to GitHub. So we added a new commit here, and we need to publish that to GitHub. Actually, right now, I'll show you the state of the repo. So this is the repo in GitHub. To get started with GitHub, it's pretty easy. You sign up for an account. You just need a free account. There's a paid version, but I've never needed it. And you can create a new repo right here. So we already kind of went through all that for this repo. And as you see, GitHub only has kept track of my initial commit because I haven't pushed anything just yet. Let's see. So now I'm going to go ahead and push the commit I made. So right now I'm actually on the main branch, and I'm pushing to the main branch. This is unusual. Usually you don't want to do that. You want to be merging into the main branch. But for now, for the sake of an example of pushing, I will go ahead and do that. Okay, so we run a git status. It looks like everything is up to date. If I take a look at GitHub, if I refresh this page, looks like it says I added food to the menu. Yeah, so it looks like we're good to go. Another big use for GitHub, as I mentioned, is collaborating with others. So this menu I'm making, I'm not working by myself. I'm working with a friend, my good friend, Kanye West. Kanye West is also going to contribute to this menu as he sees fit. And so before he does that, he's going to fetch my repo. So at this point, he's already cloned my repo. The cloning process is also pretty easy. Usually if I'm like looking at a repo and I want to clone it, I would go to GitHub. It gives me instructions here on how to clone. You could either copy this URL or this. I guess they also have a CLI now you could use. I haven't used that before, but also seems fairly straightforward. So Kanye West has pulled my changes from the Git repo. And as you could see here, actually one sec. Oh, he just fetched it, so let me pull. So notice when I contributed, I did git push. The reverse of that is git pull. And git pull essentially does a git fetch and a git merge. So fetch only updates knowledge of what changes exist. A merge brings them into your local repo from the remote repo. So here, if we do a git log, now Kanye West has access to the changes I made, and his local repo is up to date. So right now, what we want to do is try and add something from Kanye West's side. He has a contribution to the menu as well. He's thinking that, let's see here. Right. So currently we only have like green beans, plantains, and turkey in here. Sure, there's green beans, but not a lot of vegetables. Kanye is always thinking about the kids, so he's going to create a new branch for this feature of his. So the way we create a new branch, there's various ways to create a new branch, but my favorite is just say get checkout dash B, and then let's say call it beats for the kids. So in this branch, Kanye is going to add a new recipe of beats to the repo. Okay, and as you see, the color changed to reflect that a new file has been added. Cool. And so we added the new recipe. We're also going to want to add that to the menu. But we don't want to just add this to the menu willy-nilly. We want to separate out what the adults are eating and what the kids are eating. So we'll go ahead and do that. Should call this the main menu. And then we'll call this the kids menu. Super healthy. Okay, let's save that. All right, so checking the status, you can see that the menu file was modified. And the reason these are in separate areas is because the menu file was already being kept track of. The beats file was untracked, and so that is in the untracked files area. But if we just do a git add, so this adds everything in this directory, and so you could add specific files if you change that argument. So everything's been added and is ready to be committed. So we'll go ahead and commit that. Okay. And locally, you can see that our commit exists. And this is where our head is. But these are some of the remote branches, and they aren't up to date just yet. And if you do a git status, you could see that we need to actually, so we need to, before we are able to merge our commit on let's say my repo, Kanye West needs to keep track of his changes on a remote repo. So we'll go ahead and do that. So here what I did is a git push -u. -u means upstream. So that says for this branch right here, this is going to be the name of the upstream branch. And so as you see, I created a new branch here, a new remote branch. So this is over at GitHub, and it's keeping track of my local branch. So if I run a git status here, you see that everything is up to date with this remote branch. So after that, what we want to do is merge with the main branch. And before we do the merge, I'll go ahead and explain a little more what that looks like. Yeah, so next problem is like unifying these two branches. So we're currently here. We've developed a new feature. We want to merge it into the main branch. There's various ways to do this. You could either do a merge or a rebase. What a merge does, let's say, as you're developing this feature, somebody else added new changes to the main branch, and you want to kind of keep track of those changes. You can either call a merge, which creates a new commit of kind of unifying these changes. So your feature branch will have a whole new commit that is a merge commit. or you could do a rebase. A rebase essentially changes the base of this feature branch. So previously, these two white commits were the base of the feature branch. That's where the feature branch was built off of. But because we want to now reflect some changes that happened on the main branch, we call a rebase, which then changes the base of the feature branch to these two blue dots. And then these are all seen as new commits, but they're just these three changes we made. So we don't have a merge commit created at the end here. We just have these commits moved on top, moved from being based here to being based here. And that's pretty much it. So for example, here, let's see, if we go back over here, and let's say we add, again, I'm going to add to the main branch. Usually you wouldn't do this, but for the sake of time, let's say I add mashed potatoes. Mashed potatoes is a pretty popular Thanksgiving dish. And as you know, let me know if I'm falling behind on time. And I want to keep time for questions as well.
You're doing great.
Cool. So I add mashed potatoes, and then we want to add that to the menu as well. Cool. I want to add that, commit. Boom. All right, and then we want to push that. So I've added a new menu item, and perhaps Kanye West wants to take a look and see, has Paul made any changes? Do I want to update my branch to kind of keep track of these changes? So what he's going to do is just going to do a, let's see, just do a git pull. Looks like there's some changes. He takes a look at the commits. Oh, wow, look, Paul added mashed potatoes. I better update my previous branch to keep track of that. The way you go out to the previous branch, sometimes if it's a long name like Beats for the Kids, just get checkout dash and you're good to go. Very similar to CD dash. There's a little bit of consistency there. It can get annoying with some inconsistencies, but at least this is fairly consistent. So here, I prefer rebase because I'm not a big fan of this extra commit. And rebase kind of shows a meaningful timeline of the events. So just do a git rebase here. Actually, not that. Just do git rebase master. Okay, cool. So on this git rebase, it looks like there's a conflict. If you can remember, we added a whole bunch of stuff to the menu. We changed, we separated out the main menu and the kids menu. But Paul added mashed potatoes to the menu, so there's a conflict there. There's various ways to handle these conflicts, and you could either open the file and deal with the conflict yourself, but that is pretty ugly. It has these weird markings to show where the conflict is, and they're honestly pretty confusing. I think, yeah, so it kind of looks like this, and what the hell is going on? I have no idea. There's a much easier way to deal with this. So if I run git merge tool, you could also do this in VS Code pretty easily. But as you can see, the merge tool here shows us some changes that happened on the other side. So mashed potatoes were added.
Could you increase the font on this?
Yeah, let's see. I'll try.
If not, that's fine.
Try Zoom here, one sec. Oh, geez, never mind. I guess not. But yeah, I hope this is sort of clear. It is pretty tiny for me as well. But as you can see, these are some of the changes we made. Um, and these changes were made by the other side. We don't want to have to choose between one or the other. So what merge tool does here is let us choose either the left side, and here at the bottom it shows you what it's going to look like. I think that's for change. Let me just make sure. Oh, okay. Right side. Yeah. So here, if we choose the right side, it's only going to pick the changes we made and leave out the mashed potatoes. But really, we want both. So if it, oh, seems to be an issue here. One sec. Oh, I see. I see. Maybe resolving one issue. One second. Okay. Choose neither. It's just going to keep. Okay, I see. So it's resolving just the issue with the main menu. And so I'm going to go with, I think if I choose right side or both, either one works because we want to keep the title for the main menu. And then after you're done, you just save. I usually would hit Command S, but just to show you the save here, I save. And then I quit merge tool. So I go back here. Looks like that's done. Okay, and we're still in the rebase. So all we got to do after that, after resolving the conflict, is just say rebase, continue. Okay, and looks like it made the change. Let's see here. Okay. It looks like no files need merging. So let's try and get pulled real quick here. Okay, it looks like it's doing a merge commit. I may have skipped a step, but let's just put this away for now. So it looks like my addition to the menu was left out. Might be an issue with the merge tool. So actually what I'm going to do here is try to undo this commit. There's various ways to undo a commit. You could either, and I was going to get to this later, but I guess this is fast forwarding to that. You could do what we call a git revert. So git revert selects a specific commit and pretty much undoes it and creates a new commit for that. You could also do a git reset. Git reset pretty much undoes the commit, gets rid of it in the git log, and I guess rewrites history. Only recommended for your local repo, not for doing in like something that's publicly shared. And you could also do a git checkout and then kind of make a new commit yourself. So what I want to do here is take a look at the log again. So I essentially want to get back to this state right here. So you could either copy the commit hash, or it's a way to just go back several steps behind the head. And I'm going to show you here in a sec. So there's various options for git reset, but the relevant one right now is reset hard. Okay. So as you see, the commits were pretty much thrown away, gotten rid of. This is fairly dangerous because if you have changes that you aren't sure if you want to get rid of, this is virtually irreversible. There's ways to reverse it, but like it's something you want to be careful with. So here, looking at the git log, showed us that the commits were gotten rid of, and then git status shows us that there's different commits. So what I want to do here, I want to try and do this merge again. Nice. Let's try Git then. All right, looks like I may have missed a step there, but we'll move on anyway, and try to save some time here. Okay. Yeah, so as I mentioned, merging versus rebasing are some of your options for making changes and merging them with the main branch. And then you saw some stuff with undoing changes. This is essentially moving back in time. A little review for undoing these changes. As you saw, we would make a change to a file, add that to the staging index with git add, and then commit that with git commit. And then in addition to that, we would do, let's say, a git checkout to maybe look at a different branch. And this is pretty much showing how we're moving across the different parts of the Git structure. So your working directory is where you're making your changes. And then once you add those changes, you're putting those in the staging index. And then when you commit them, you're pretty much keeping track of the state in your repository. And then you could check out files from this repository that have been kept track of as you would like. So that brings them back to your working index for you to make changes to. Yeah, and so this is an example of that. So let's say you have a specific commit and you're on git checkout for that commit. It puts you at that commit. And git revert, as I mentioned earlier, you would undo a commit, but you're adding essentially a new commit saying, hey, I undid this commit, whatever changes were made in there, I undid them, and then you push. This is preferable for public commits. So if a commit has already been pushed to a shared repo, you don't want to, I guess, delete it. You just want to reverse its changes and keep track of that. Because when you delete it, you're pretty much changing the timeline of things. And this timeline is shared and accessed by everybody you're collaborating with, which can get pretty confusing and disorganized. So you don't want to do that. So the best way to do that is to do a git revert, which just says, in this new commit, I am undoing the changes from this old commit. So if in this old commit, I, let's say, added like soda to the menu, but realized here, oh, I don't want soda in this menu, I do a git revert, it deletes soda, leaves this commit still, but in this new commit, it says, I undid the changes from the commit where we added soda to the menu. And then there's git reset. Git reset is only recommended for commits in your local repository. And so again, if you remember, we have your working directory, your staging index, your working directory, stuff you're working on. Your staging index is, after you call like git add, it'll move your changes to your staging index, and then when you commit them, they get added to your repository. So git reset has a few options. So first you have git reset soft. So if you say git reset soft, a specific commit, it will reset the state of your repository to that specific commit, and all the commits between where you were before and this specific commit are pretty much undone, but the changes aren't thrown away. The changes are simply added to your staging index. So if you want to kind of not do that reset, you could just say git add and then get commit. So those changes are then restored. It's sort of like a safe way to reset without necessarily completely throwing away all your changes. But then there's other ways to also do a git reset. The default way to do a git reset is called mixed. So it undoes the commits between where you're at and the commit you want to reset to. And any changes that are in the staging index, so if you've called git add on a specific file before, will be moved to the working directory. So they will be moved from here to here. So they will look as if you made these changes but didn't add them just yet. And this is also, if you want to reset, but you had some stuff you were working on, you haven't yet added or committed it, but you don't really want to get rid of it. This would help with that. And then there's get reset hard. This is pretty powerful one, but with great power comes great responsibility, and can be pretty dangerous as well. This undoes commits and discards all uncommitted changes. So if you have stuff in the staging index, if you have changes you've made and you've saved but you didn't really add them or commit them, it will undo all of that and throw it away and just pretty much reset your state cleanly to whatever specific commit you want to go to. Pretty helpful for quickly cleaning up your environment and just kind of going back to a previous state. But also, if you're not careful, could get rid of your hard-earned work. So a quick review of undoing changes. Git checkout just restores the repo to previous commit. Revert creates a new commit, but without the old changes that you want to undo. And then reset will just specifically undo commits. You have the soft option, the mixed, and the hard. And reset is safest to use in your local repo when you're just kind of still working on a feature by yourself and you haven't really shared this with anybody else. Not recommended for working with on the main branch. Overall best practices. It's recommended to use branches when you're developing features. So in most cases, it's not recommended to develop on the main branch. It's only for things that have been green lighted and good to go, so that when mistakes happen, you aren't messing up the main branch. So as you saw in the past year, yeah, I had some issues, and with some more time, I'd probably figure it out. But it's great that this happened on a branch that's not the main branch and wouldn't ruin the history of the rest of the project. And it's recommended to make atomic commits. What does this mean? This basically means, your commits should be of related changes. So if I added, like mashed potatoes to the menu, that should just be mashed potatoes. If I added, let's say, a bunch of desserts to the menu and mashed potatoes, that's not an atomic commit. It's a bunch of things that are unrelated. And so this makes it difficult to understand the context of these changes when someone's looking back at them later. Yeah, it's probably fine. It's probably not a big deal. But in terms of like understanding how the changes are happening to the code base, it's a little difficult. And if I wanted to undo just the desserts but not the mashed potatoes, then I'm in a little bit of a tough situation here. And then also commit early and commit often. This simply just helps you like save your work. It's just like if you're writing in a Word document and you save, it's recommended just in case things happen. And also don't commit half-done work. A good way to do this is use git stash. This is because if you have too many commits that are still meaningless and it's just like, oh, it was a Friday, I wanted to like save my state. It's hard for whoever else is reading the Git log or reviewing your code to understand exactly what was going on, exactly what was your train of thought. And then it's also recommended to test before committing. That was kind of hard to do that today. There's not really much to test, but usually if you're working in a code base, there's ways to test your code. So you don't want to commit stuff that is untested and unproven. Maybe that's pretty straightforward. And then you want to have clear commit messages that are pretty understandable so that whoever is reading your code understands the purpose of whatever changes you're making. Yeah, and then this is just some quick fixes for common Git errors and mistakes. I won't get into many of them in the best interest of time, but one that I've had to deal with in the past, I called the git reset hard by accident, just by my terminal suggestions, and got rid of like a lot of work I had. And after some Googling around and Stack Overflow, I found this way to use the reference log of Git, like git ref log, to look at all my past actions, and it kind of like saves all the states you have, regardless of whether you were like undoing commits or like getting rid of stuff. And I was able to go back to whatever hash for the reference before I'd called the reset hard. This reference log is saved for, I believe, 30 days. And so, that was just like 2 minutes of time that had passed. So that was pretty helpful. And I was able to reset to that. I lied. Reset hard isn't, immediately discard everything, but kind of is. It's sometimes if you have changes in your working index that aren't saved, those will disappear because you haven't committed them yet. And so Git doesn't have knowledge of them. But if you've committed stuff, if you've committed early and often, most stuff is recoverable, and I was saved 2 hours of work that way. But yeah, that's pretty much it. I hope some of this was easy to understand, and if not, a lot of resources out there that have gone into how to use Git, and like many other things, you learn by doing. So I hope this was helpful. Thanks, Ajna, for giving me the opportunity to kind of share some of this knowledge. And I also would like to acknowledge that a lot of the imagery wasn't mine. I kind of borrowed it from the Altacian website. Thank you.
Thanks, Paul. We actually have a question if you have some time. We have a couple minutes.
Sure.
Ella, do you want to unmute and ask it, or do you want me to say it for you? Okay, so the question was, what's the difference between git pull and git fetch, and when do you use one over the other?
Yeah, so git pull, so there's this thing called, I guess, git merge. I might have talked about it earlier. Git pull is essentially git fetch and git merge. Git fetch would just be to see, are there changes that I haven't updated to? And so you just run a git fetch to take a look and like get a sense of that. But that doesn't quote unquote merge the changes to your repo or to your working directory. Git pull will automatically do that. So if there are changes out there and you're just sure of them, you're sure they won't break anything on your end. Git pull is a way to like shorten the 2 steps you would need to merge those changes into your repo.
Great. We have a couple raised hands. I think I saw Adelaide's first.
Yeah. Hi, Paul, and thank you for your amazing presentation. I hope you're a little bit familiar with Visual Studio Code. So my mentor and I are building a web application using Flask and Python, and one of the requirements was to download Git. Now, through our workings together, he was working me through how to pull and push using a Visual Studio Code, and I was interested or curious, is Git responsible for assisting the pulling and pushing of code to GitHub? Does that make sense?
Yeah, it does make sense. If I understand your question, you're asking, like in Visual Studio Code, when you pull and push, is Git involved with that process, right?
Yes.
Yeah, it is. So in Visual Studio Code, I believe you're talking about, there's like buttons you could press to pull and push. When you press those buttons, like internally in the back end of Visual Studio Code, it's just calling the commands for git pull and git push on that end. Yeah.
Okay, thank you.
Mm-hmm.
If there's another question, feel free to unmute. I also wanted to add that you can use Git locally without using the internet. So if you're someone who's in a place where data is expensive, the only parts that use data is the pull and push. You can commit. Paul, you can correct me here. I think you can commit without having to use internet. It's only when you push all your commits, which you can have multiple, that you use data for that.
Yep, that's correct.
So Paul, while we're waiting for questions, what version control do y'all use at Apple?
Yeah, we use Git pretty universally, I think. The only other one that I've seen used is this thing called Perforce, and that's used for like circuit designs and like board layouts. But for everything else, Git is what's been used for software mostly.
Yeah, I think Google uses Perforce as well, but there's a ton of different ones. It really depends.
Yeah.
Does anyone use a different version control at their work or at school?
Sorry, so far the one I'm only familiar with.
You mean like system? So we use Git, but we use the Bitbucket.
Okay.
Bitbucket, yeah.
Bitbucket is very popular. Sorry, Del, I think you got cut off there.
No, it's fine. And I was just saying I'm only familiar with Git. The other ones are quite new to me. Like, what did you say? The one that Google uses and you, Paul?
Perforce?
How do you spell that, sir?
I put it in the chat.
Okay. Because I'm familiar with Bitbucket, and my mentor also introduced me to that one. But we started off with Git because I guess it's the most famous one, and it's easier for me at least.
We have another question. Halima asks, is there a recommendation for how many branches to use per project, or when it makes sense to create a new branch?
Good question. In some projects I've worked on, you could create a branch for like a quick fix, and then some other projects, it's mostly just big features. But a lot of time you could create as many branches as you want. And some projects I've been on, branches are deleted after a merge to master. In other projects, we've made sure not to delete the branches just in case we want to like take a look at history. But yeah, I think you're fairly free to create as many branches as you want. I haven't seen anyone have an issue with that, as long as you name them in a way that's understandable.
Yeah, I've also seen people who have like a staging branch, which is almost exactly the same as the main branch, except it has like you push to staging first, test on staging, and then you push to main or master before. That's the one everyone sees. So I know that that's also a common branch that doesn't get deleted. Or name. You can call it whatever you want, but that also happens for some folks. That's really cool. Awesome. We are right at time. Thank you so much, Paul, for doing this. Are you comfortable sharing the slides? We're going to share this recording out afterwards, but some people really enjoyed your slides. But I also said in the chat that there are a lot of Git cheat sheets around. So if you Google Git cheat sheets, you'll see a few. GitHub has some that can kind of help you remember all of these commands. There's some I don't use. But thank you so much, Paul, for your time. This was super helpful. We really appreciate all the effort you put into it. I really love the presentation.
Of course. Glad I could help.
Thank you, Paul.
Thank you.
See y'all next time at AfricodeX. We'll let y'all know soon what the next topic is going to be, but we're excited about it.
See you.
See you.
I see you.